In today's lesson, we are going to be looking at the present value of ordinary annuities. So this is similar to what we looked at when we looked at the present value of compound interest questions. However, we're just going to be kind of looking at the same thing just with annuities. So the present value of an ordinary annuity is the amount that must be invested now or today at a given interest rate or compounding frequency in order to provide regular annuity payments over a certain period of time. So just to review, an annuity means a series of equal payments at equal intervals over a fixed period of time. So now these situations are going to be asking how much do we need to have today, or what do we need to have now in order to have a payment over the specific period. So the formula that we're going to be using, we are going to be using our present value compound interest formula. So the same thing that we've looked at before. And when we use the TVM solver, we are going to be using or stating that the future value equals 0. So this is going to be something more where we're paying something off. Right? We want to figure out, okay, what's the initial payment or what's the initial cost, so to speak. So Devin has purchased new furniture. The store has given him a payment of $245 every 6 months for 3 years. The interest rate is 14% per year, compounded semi-yearly. So similar to when we looked at annuities for like the future value, we want to look at creating a kind of timeline diagram and then working from there, figuring out what is the actual cost of the furniture, because these payments have the interest already included in them. So they've already gone through, they've calculated the interest, and then they've created these payments for each, or for Devin. So we're going to use a timeline diagram, figure out the actual cost if he was to pay for it today without going on that interest rate plan, and then looking at how much interest he did have to pay by choosing that plan. So again, the timeline diagram, similar to the last lesson. So looking at every 6 months. So this is year 1, 2, and 3 into this payment plan. So we are going to calculate the present value, because we're looking at, okay, if this present value, if I know that I'm paying $245, what is the actual value, right? Let's take off the interest and figure out what is the actual value. So I do need to calculate, again, if we go back to that formula, I do need to calculate I first, similar to what we did last time. So 14% or 0.14, because it's compounded semi-annually, I'm dividing by 2, 0.07. So 245 times 1 plus 0.07 to the power of negative n. And in this case, the n value is kind of referring back to how many payments am I away from the initial value, or from today, right? So if it's only been half a year, this is only one compounding period from the initial purchase. So in this case, I go through and I calculate $228.97. That's the initial price, or the initial cost. At 1 year, again, I'm paying another $245. I want to find out what is that initial cost, or what is what is the value of that payment presently minus the 2 compounding periods of interest. Just move this over slightly. And when we go through and calculate, we get 213.99. So that's the present value cost. At 1.5 years into this payment plan, again, I pay another $245. I want to figure out what is that initial or present value of that payment. So if I didn't have to pay all this interest, what did it actually cost me? So I am 3 compounding periods away from the initial purchase. Present value, just under $200. At 2 years, again, same idea. Let's actually just move this down a bit. Same idea. I'm still making a payment of $245, but this has some interest already included into it. I am 4 payments or 4 compounding periods away from the initial purchase. So to go back and find the present value, I get a value of 186.91. 2.5 years, again, same idea. Another $245 payment. There is interest tacked on to this one. There's 5 compounding periods. So to work backwards, $174.68 would be the original value of this purchase. You might say, well, it's decreasing, right? Why is it decreasing? Why are my original values getting smaller? Well, again, that's because the further away from the initial value, there's more compounding periods, and then so more interest is added on. You have to remember the store has already predetermined that based off of your entire purchase, with the interest, you're paying $245. So we're just trying to find the original value, and in the end, it will work out. So PV, so again, last year, $245 times 1 plus 0.07 to the power of -6, because there would have been 6 compounding periods onto this year. And we get a value of 163.25. So we have all of our payments, or what all the present value of each payment is, in order to have that overall value of $245. So these are all the present values of what the payment was actually worth without the interest. And for B, or well, not for B, we can also do the same thing and go through and find or enter this into a TVM solver. Right, so we could go through and answer our questions. We can also use a TVM solver so that we don't have to use this timeline, similar to when we looked at the annuities in the previous lesson. The whole point of the TVM solver was to kind of reduce this kind of repetitive calculation. So our end value, there are still 6 payments or 6 compounding periods twice a year for 3 years. The I is 14%. PV we don't know, that's what we're looking for. PMT we know is $245. The future value is 0 because we would pay off 0. Or sorry, in the future we would have 0, we've paid it all off. 2 payments per year, 2 compounding periods per year. So we can go through and calculate the future value, or what the actual cost of the furniture was. Or sorry, not the future value, the present value, which is the actual cost of the furniture. So let's go through and do that first, and then we'll do it by hand, and then we'll double check our values with the TVM solver. So again, all we're doing is we're going back and we're adding up all these present values. So we add them all up, so 228.97 plus 213.99 plus 199.99, 186.91, 174.68, 163.25. So again, those are all of our present values. We add them all up, and we should get an amount of $1,167.79. Again, we can double check this using a TVM solver. So again, you can Google it, go to the GeoGebra one, because it does allow you to enter in all of the key information. We can enter in everything we just mentioned. So we have 6 payments, compounding periods over the total plan. PV we don't know. PMT is 245. Future value is 0 because we've paid it off in the future. 2 and 2, and we go and we solve for PV. And again, we can see that we do get the same value. They've rounded it up. So instead of 279, or sorry, 8 instead of 79 cents, they've rounded it up to 80 cents. Right, so off by $1 or off by a penny, but again, we have the same value. So that means that if we weren't going to go on this payment plan, the original cost of the furniture was $1,167.80 or 79 cents, depending on how you're rounding. In any case, Devin decided to buy or go through this payment plan. So he's decided to pay the $245 a month rather than pay for the furniture right off the bat. So how much interest did he actually pay? So how much extra did he pay than he needed to? Well, we can take the $245 payments. We're going to multiply that by 6, which gives us $1,470. So that's how much he actually paid. Right? That's the amount he paid over the 3 years. Right? That's the payment plan they set up. So to figure out how much interest he made, or how much interest he had to pay, we take that total amount that he paid, we subtract the present value, which was the 1,167, and we'll make it 80 cents. And we should get $302.20. So that means that he paid over 3 years an extra $302.21 to do that monthly payment plan rather than pay it off in full. And again, that's kind of the consequence of going with these payment plans. You're no doubt going to be paying a bit more with the luxury of not having to put up a large chunk of money right off the bat. So that's kind of where it balances out. So again, the main thing from this lesson is just to kind of see how this can work in the other direction, where we want to find the present value based off of a payment plan rather than the future value. Key things, again, remember the future value in this case is 0 because we've paid off our plan, so to speak, or we've paid off the cost of our item. And then again, we're looking for the present value. We could use a timeline diagram, but again, using the TVM solver like we just kind of saw here, which did give us that same value of $1,167.80 is a valid option as well. And again, it's the same kind of concepts, but looking at more the present value. So kind of how we looked at the present value in compound interest, now we look at it